So, question 13. Student uses the apparatus in figure 3 to determine the specific heat capacity of water. So we did something like this. I think we used an aluminium block instead of water, but we've got our immersion heater, a thermometer, power supply. We did something very similar to this in class. So state the measurements needed to calculate the specific heat capacity of water. So let's think about this idea of what is this specific heat capacity. Well, the equation will look something like this: mc delta theta. Energy, the mass, times the specific heat capacity, times the change in temperature. So rearranging this for specific heat capacity is E over m delta theta. So state the measurements to calculate it. We need the energy, we need the mass, and we need the temperature change. So what measurements are we going to need to take? Well, big clue here. Joule meter measures the energy, thermometer for the temperature, and we're going to need to find the mass, and that'll be those three complete. So let's make a little note of them. So the first thing is, let's go through it, the energy supplied. So we can say use the joule meter to measure the energy supplied. Number two, let's see, we need the mass. Okay, please note it's the mass of the water alone. So let's think about how we're going to get the mass of the water. So let's say use a balance to find the mass of let's go A, the water and the cup, and B, the empty cup. Then take A from B to find mass of the water. And then lastly, the temperature change. That's a triangle, delta. You just change, and the theta, this capital O with a line in the middle, that's the temperature. So that's temperature change. So we're going to say use a thermometer to measure the temperature at the start and the end to calculate the change in temperature, delta theta. Last one, state 2 ways the apparatus could be adapted to improve the accuracy. Well, we've got loads of things going on here. We're going to get some heat loss from the outside here, some through the top. So we can look at insulating the sides of the cup. We could put a lid on the cup. What else could we do? We could stir the water gently. If we look at the heater, not all the heater is submerged, so we could look at using a more suitable submerged heater. Oh, anything else? Possibly the sensitivity of the thermometer we could look at yet. But I think we've got 4, we only need 2 there anyway. That's a good job.